This is Precalculus, Chapter 1, Section 2, Problem number 91, A and C. Again, we're rationalizing the denominator, but instead of just square roots, we could have any root in the denominator. And in this case, we have a cube root. Currently, our radicand is just x to the first. And to have this rationalized, to have no radical here, I need the radicands to be powers of 3. So it could be a power of 3, or a power of 6, or a power of 9, power of 12. Any of those multiples of 3 powers in the radicand, then I will be able to clear it out of the radical symbol. Since I've only got x to the first, I realize that what I need to multiply it by is x to the second, so that I would have x to the third as the radicand. And so I do that, and now this denominator, I've got x cubed as my radicand under the cube root. Since this is a multiple of 3, it's one multiple of 3, I get 1 x to the first in the denominator. Again, the numerator is not as much a concern to me, so I have a 2 times the cube root of x squared, and that just kind of follows me through. In the second problem, we don't see that it's a radical, but remember that y to the 2/5 power could be written in a radical form, and so this denominator of 5 in this exponent does mean that it is a 5th root. So currently I only have y squared under the 5th root, and I need multiples of 5, so I need y to the 5th or the 10th or the 15th, but I can easily make this y to the 5th by multiplying by y cubed. And you might look at this and say, I don't see how that's y cubed here, but it is y cubed under a 5th root. If we look at it we change it from exponential to radical form. And now we're going to be multiplying the 5th root of y squared times the 5th root of y cubed, and that's going to give us the 5th root of y to the 5th. So these will match, and therefore the denominator will be rationalized. And again, all I do now is I just do x times whatever this is up here, so I have x times y to the 3/5.